All right, today we are going to cover area, the basics of that. We are starting into a month or so on geometry. So in this, let's go ahead and make a quick table about the different dimensions for geometry. If you have 0 dimensions, that would just be a dot. 1 dimension would be a line. 2 dimensions could be not just length. 1 dimension is length. 2 dimensions then is length times the width. And then if we have 3 dimensions, we have the length times the width times the height. Don't worry about making your drawings look too good. Length times width times height, not height. Okay, so there is no formula for 0 dimensions because you can't measure 0 dimensions. It's the null set. It's nothing. 1 dimension is just length. 2 dimensions, length times width. 3 dimensions, length times width times height. We're going to be dealing with 1 dimension and 2 dimensions now. Later in the year, we'll deal with 3 dimensions. So what does this measure? 0 dimensions doesn't measure anything. 1 dimension measures length. 2 dimensions measures length times width, which we also call the area. And then 3 dimensions is length times width times height, which we call the volume. There is not a 4th dimension in math. Some people say a 4th dimension would be something like time, but we're not dealing with that. Okay, so common units of measurement. Well, for 0 dimensions, we're not measuring anything. For 1 dimension, we could measure it in centimeters, or inches, or feet, or miles, or light years. You know, there's all different kinds that we could use here. For 2 dimensions, now we don't just have centimeters, we have centimeters times centimeters, so square centimeters, square inches, square feet, square miles. It has to be squared. Okay? And then in the same way, for volume, it's centimeters to the power of 3 cubed, cubic centimeters, cubic inches, cubic feet, cubic miles, cubic whatever we used, our length to the power of 3. So it's cubed. Let's write that word in there too if you have room. Cubed. And then for 2 powers, it would be squared. All right, so today we're doing area, 2 dimensions. Tomorrow we'll do perimeter, which is back to just 1 dimension. Okay, so what is area? Area is going to be the total space inside of a geometric figure. Today we're going to deal with squares and rectangles. We're going to deal with right angles. Later in the year we'll do other things too, like triangles and circles and other area. Okay, so some real world examples. We could come up with a lot of them. If you're replacing flooring, so it'd be like the carpet on the ground. You could measure a window, how many square units it is to see how much light we're letting in. If you're paving a parking lot, you would want to know how many square meters it is, or square yards, or square feet. If you're painting a wall, important. Okay, so we're not figuring out the volume, we're figuring out just 2 dimensions. All right, so to find the area of a rectangle, we said we're going to multiply the length by the width. Okay, so let's look for formulas, and we'll come up with our formulas here. Well, we just said it's length times width, so formula is A equals L, and for L we do cursive, times W. So I'm just putting them next to each other. Big A equals cursive L, W. All right, so the area of a rectangle on a grid. So let's look at this. Let's find the length. 1, 2, 3, 4 units is my length, times my width, which we could also say is our height here. 1, 2, 3, 4. 4 times 4, which is 16 square units. We always want to label. We also could have said units to the power of 2. Either of these answers is acceptable. We could count each one, but we know if it's 4 by 4, 4 times 4 is 16. Okay, so let's look at the area of this rectangle with 1-digit sides. So the bottom of this is the same as the top of this. 6 feet times 4 feet. Length times width. 6 times 4 is 24. Feet times feet is square feet. 24 square feet. Okay, we could have drawn this, broken it up into 6 by 4, and then counted them all, but that just takes too long. Multiplication is a shortcut for repeated addition. Okay, so now let's get a little bigger. Area of this rectangle with 2-digit sides, 27 times 9. Okay, so we just need to work out 27 times 9. I could do 27 times 10 in my head and then subtract 9, but I'll use the old algorithm here. 243. That's not right. Yeah, it is. 1 less than 243 square yards. All right, area of a rectangle with a fractional side, 7/8 times 3/5. Remember how we do this. Multiply the numerators, multiply the denominators. If we can simplify early, it makes our life easier later on. Then we don't have to simplify at the end. There's nothing to simplify early, so we know it's already simplified. Square centimeters. Okay, let's look at the story problem. Tony is fertilizing his garden. The garden is in the shape of a rectangle. Remember our kiter techniques? We look for key terms. We could illustrate. We could make a T-chart. We look for easier numbers, and then we always ask if it's reasonable. I'm just illustrating right away. I like to do that. Its length is 15 feet, and its width is 13 feet. Suppose each bag of fertilizer covers 39 square feet. How many bags will he need to cover the garden? Well, first let's figure out the area of the garden. 15 times 13. And I believe this topic has a calculator for you. I'm just going to work it out real fast. So we know it's 195 square feet total. Don't just write 195 feet inside of it. Make sure you have that squared. That's important. Suppose each bag covers 39 square feet. So one bag, 39. Another bag, 39. Another bag, 39. So this is repeated subtraction or division. So we're figuring out how many 39s fit into 195. And the answer to that is 5. So you need 5 bags. Before I move on, I need to make sure that makes sense. Would it make sense that 5 bags would be able to fertilize a garden? Yeah, that makes sense. You can fit that in the trunk of your car. All right, let's go into the next question. Oh, we're going to look at the area model now. Okay, so a rectangle has side lengths of 2 and 178. So 2 times 178. Here's a rectangle split into smaller rectangles. Find the missing lengths, then find the area in square units. So this area model is how we really do multiplication. 100 plus 70 plus 8 is 178. So we're just breaking it up. 100 times 2 is 200. 70 times 2 is 140. And then 8 times 2 is 16. So the answer to this is 200 plus 140 plus 16, which is 256. No, it's not. It's 356. 356. Okay, it would have made sense for me to write that down. Now I did do the reasonable step, which made sure I knew how to do it. All right, So that's what we're doing today. This should be review stuff of the area. Your homework or your classwork now will have topics that look just like what we did there. Good luck.